In this video, I want to talk specifically about how to map two triangles to be congruent. And in this case, we're talking about the angle-side angle situation. So here are my two triangles. They're actually from the construction before, but I cleaned them up a little bit and tried to make them look a little better. So the first thing we want to do to map is we want to translate the triangle so one pair of vertices lines up. In this case, I'm going to translate this distance right here. I'm going to make it so that point H and point D line up. So this would be vector HD. So vector HD translation. Alright, so let's say we translate to there. Then the next thing we want to do is line up the second pair of vertices, which are X and E. So that would be a rotation about this angle. And it's angle XHE. I'll write that underneath here. Okay, so I'm going to go ahead and rotate on that angle. Okay, now you can see that two pairs of vertices are lined up. There's the translation and the rotation. Okay, now the third transformation is going to have to be a reflection. And that reflection would hopefully match point O to point F. Okay, so how do you make the argument that this is indeed a reflection? Well, let's take a look. Angle D is reflected to create angle H, because those two angles are congruent. Angle E is reflected to create angle X, because those two angles are congruent. Now notice that point O lies on DO, so it also must lie on HF, because it's a reflection. Point O also lies on XO, so it also has to lie on XF or EF, depending on which point you want to call it. And that's also because it's a reflection. So since point O has to lie on HF and XF or EF, depending on what you call it, or it could be, this is where it gets a little confusing, because you have H and D and X and E, but really those are the same point. So what I'm going to do is I'm just going to make this a little bit easier. Okay, so since point O lies on HO, it also lies on HF because it's a reflection. And point O also lies on XO, so it has to lie on XF because it's a reflection. So since point O has to lie on both segments HF and XF, it has to lie on point F. That's the only way it could be on both segments here. Therefore, you do have a reflection situation, and you can say that the triangles are congruent. So the third transformation, let's go ahead and do that. There's the reflection. And there you can see that the triangles are congruent. So that's how you map the transformations for an angle-side angle congruence.